Machine learning-empowered solutions are increasingly utilized to solve real-world business problems. However, with the rising data privacy concerns and the introduction of stringent privacy protection laws like GDPR, it is increasingly challenging for organizations to access sufficient user data to train a good-performing model. This is especially the case for business sectors that require sensitive training data, such as the healthcare or finance industry. In response, federated learning has emerged as a promising machine learning paradigm that enables privacy-preserving collaborative model training. Multiple data owners can collaboratively train a shared model without exposing their data to third-party servers. Federated learning shares several similarities with crowdsourcing. While crowdsourcing platforms such as Amazon Mechanical Turk enables task publishers to outsource their work to a distributed workforce, federated learning leverages on the computing capabilities and data resources of the clients. However, the development of a crowdsourcing-based marketplace for federated learning is still in its infancy. Hence, we developed CrowdFL, a marketplace for crowdsourced federated learning. It serves as a bridge between data demand and supply by providing end-to-end functions to facilitate efficient federated learning model training. The CrowdFL application can be used by both the model owner or the data owner. Firstly, we assume the role of a model owner that intends to train a model for diabetes diagnosis. After login, we go to the dashboard to list a new training task. Here we fill in our training requirements, task description, data attributes required and training start time. We also upload an initial model and a test dataset, which will be used for model training and testing respectively. After successfully listing the task, it shows in our dashboard. Next, we take the role of a data owner, which we refer to as a client. After login, we can view all the available listings at the Explore page. The detailed description about the task and data required will be shown upon clicking the task. After checking that we have the data required, we register our interest for this task. Next, we will wait for the training to start at the specified timing. When the training starts, CrowdFL sends us a notification. We then provide the data file location and join the training. Note that our data is not uploaded or shared, and the local training takes place on device. After the training is done, we receive an incentive of participation points, which we can redeem for monetary reward. As the model requester, we can now view the performance statistics and download the trained model. Other than the features shown, we also incorporated a client selection scheme to increase the likelihood of successful training, and an incentive scheme to encourage participation. We explain these implementations with the system architecture. The mobile application is where the data and model requesters are matched, and where federated learning model training takes place. The application downloads the federated learning model from the server and reads data from on-device storage for local training. Both the mobile and the server consist of three major modules: AI Engine, Client Manager and WebSocket Manager. 1. AI Engine. Before the training starts, the server automatically configures pre-processing steps according to the requirements specified by the model owner. For example, missing values are to be replaced with the average. The server then sends it together with the model to clients. After training the model locally, the clients upload the updated model parameters to the server. The server aggregates the parameters from participating clients using the federated averaging algorithm and updates the global model. It then sends back the updated global model to clients to be trained again. The training process occurs for a number of rounds specified by the model owner. 2. Client Manager. In the federated learning training environment, the data quality varies, and the model training process is susceptible to malicious or straggling clients. As such, a client selection scheme is used. Only the top clients are selected based on their reputation and device specifications. The device scores are computed based on the number of CPU cores, free RAM size and free memory space. This information is sent to the server when the client opens a socket connection to the server. The reputation score of the client is based on his prior participation in other training tasks. 3. WebSocket Manager. Client devices and server communicate through a bidirectional communication stream. CrowdFL uses WebSocket communication for low latency. In case of a broken connection, we are able to resume training as per normal using a unique identifier present in each communication message. In conclusion, our application CrowdFL provides a marketplace to match data owners with model owners in federated learning, while providing mechanisms to ensure model performance and training efficiency. In the future, we will develop on a more comprehensive data pre-processing pipeline for complex datasets.